In this video 6.5, we're going to be working with linear inequalities. By the end of the video and work time in class, you should be able to say, I can graph and use linear inequalities. To start with some vocabulary, a linear inequality with two variables, such as y is greater than x minus 3, can be formed by replacing the equal sign in a linear equation with an inequality symbol. So what we're doing is we're taking out the equal sign, we're replacing it with a greater than sign or a less than sign, or possibly greater than or equal to or less than or equal to. The solution then of an inequality with two variables is an ordered pair that's going to make the inequality true. Is the ordered pair a solution of y is less than x plus 2? In the first one, A, we have negative 5 as our x and 2 as our y. So we're going to take y is less than x plus 2, and we're going to see if this ordered pair is true, makes this inequality true. So the y, which is 2, is less than negative 5, our x, plus 2. Then we're left with 2 is less than negative 3, and we know that that's not true. 2 is not less than negative 3, so no, the ordered pair negative 5, 2 is not a solution to the inequality y is less than x plus 2. If we try 4, 6 in that same inequality, the y, 6, is less than x, which is 4, plus 2, and we see that we get 6 is less than 6. We know 6 is not less than 6, so no. However, if this would have been 6 is less than or equal to 6, then we would have said yes. But it wasn't the case, so no. What is the graph of y is less than x minus 1? Now when we graph these, we graph them just as though it was like a linear equation, y equals x minus 1. So we can see we have a slope and a y-intercept. Y-intercept of negative 1 and a slope of 1. So this is review. Now I'm just making points because now something I have to talk about is the line. The line is a solid line if you have greater than or equal to or less than or equal to. If you have a less than sign or a greater than sign, and in this case we have a less than sign right here that we're graphing. Since it's a less than sign, this is a dotted line, so we do not make a solid line in this problem. Once again, if it would have been less than or equal to, it would be a solid line, but points on the line are not going to be solutions if it's less than. So once again, this is going to be a dotted line, or if you want to put dashes through your line, that's fine. Now this is about halfway done. Now we have some shading involved. Now in this line there's points that will make this inequality true. We have to figure out if they're points that are above the line or below the line. It's really kind of above to the left of the line or below to the right of the line. So what points do make it true? So I'm going to just pick some points. I'm going to start with 0, negative 1. So I'm going to pick 0, negative 1, which is right here. So I'm picking 0, negative 1. I'm going to see if that makes our inequality true. Y is less than x minus 1, which is our inequality that we're graphing. The y, negative 1, is less than 0 minus 1. So I'm left with negative 1 is less than negative 1. And no, that's not true. So this point right here is not a solution. That means I'm not supposed to shade this side of the line because that point is not a solution. Next I'm going to pick, let's see, let's just go with 2, negative 1. So this point right here, if I select that point and plug it into the same inequality, I'm going to have, I'm going to write down what I'm picking here, which is 2, negative 1. So my y, which is negative 1, is less than my x, which is 2 minus 1. So I have negative 1 is less than 1. And yes, this is true. So this point right here is a solution. And since it's telling me it's a solution, then that's meaning all of the points that fall on the graph to this side of the line, which is below it, or I guess you could kind of say below to the right, all of the points on the graph this direction are solutions. Points on the line are not solutions. That's why it's a dotted line. Points above, kind of to the left, those are not solutions. We checked that earlier with 0, negative 1. What is the graph that x is less than 2, and then we're going to do y is greater than or equal to 3. So with x is less than 2, it's the same as if I'm graphing x equals 2. And I know x equals 2 here, 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 all of these points on the line. Now, I'm going to ignore the fact that I'm going to ignore this now. I'm taking that equation away. It's x is less than 2. Since it's a less than sign, it's going to be a dotted line, or if you want, you could make it a dashed line at x is 2. We're going to put arrows because points on that line are not solutions. Now, x is less than 2, so in other words, what's less than 2? Well, 1 is less than 2, 0, negative 4, negative 10. All of the points to the left of this line would be solutions to this inequality. Now when this other one, y is greater than or equal to 3, so if I want, think back to when y is 3, and y is 3 here, and here, and here, and here. Now we know that it's a horizontal line at y is 3. Now it says y is greater than or equal to 3. This is when we would have a solid line because it can also equal the points on the line, and anything greater than or equal to 3 is going to be above that horizontal line. So all of these points on the graph that are above that line or on that line would be true when you plug them into the inequality. Suppose you can spend no more than $20 for hot dogs and hamburgers for a picnic. Hot dogs cost $5 per package, and hamburgers are $8 per package. What are 3 possible combinations of packages of hamburgers and hot dogs that you could purchase or that you could buy? So I'm going to use, let's say, I'm going to use X for hot dogs, and I'm going to use Y for hamburgers. So it's 5 times X plus 8 times Y, and that's less than or equal to 20 because it said no more than 20, and once again we're working with inequalities. So my hamburgers is my Y, and my hot dogs is the X over here. That's our X axis. And to graph this, I'm going to use my X and my Y intercepts. My X intercept, if I plug Y or 0 in for Y, I get an X intercept of 4. And my Y intercept, when I graph, if I plug in 0 for my X, I'm left with 20 divided by 8, which gives me 2.5. So my x-intercept is at 4. My y-intercept is at 2.5. And it's a solid line because our inequality had less than or equal to. And anything less than or equal to, if we were to, the quickest way for me to figure out which direction to shade is to plug in the origin 0, 0. And if you plug 0, 0 in to this inequality that we have written out, you end up with 0 is less than or equal to 20, which is true. So that's telling us everything below this line is going to be solutions to this inequality. So when we have to come up with 3 possible combinations of packages of hamburgers and hot dogs that you could buy, you want to pick points that fall in this little area that we have shaded. So like if I picked this point right here and I said I could buy, one example here would be 3 hot dogs, 0 hamburgers. Another combination, let's say I picked, if I went like 2, 1, which ends up being right here, that's 2, 1. So that would be 2 hot dog, I'm just going to abbreviate 2 hot dog, and 1 hamburger. And then for 3, another combination, let's say just 1, 1 right here, that falls in the graph. So 1 hot dog, 1 hamburger. So there's 3 possible combinations. There's obviously other points in that area, but we only have to list 3. What is the inequality of the graph below? So I'm going to make a quick graph here, and we're going to figure out the inequality of this graph once I have this created. And there's shaded involved because it is an inequality. So here's the graph that we have. Everything is shaded down here. Okay. So what I always do when I have to name that inequality, I just start with what would the equation be of the line in slope-intercept form? So y equals mx plus b. So I see that my y-intercept right here is at positive 3, so we've got a plus 3 for the b. And when we look at the slope here, rise 1, run 2, rise 1, run 2, it's a positive 1/2 slope. So slope is 1/2, so 1/2 x plus 3. So what's left now is to figure out the inequality symbol. Is that inequality greater than? Is it greater than or equal to? Is it less than? Or is it less than or equal to? Well, we see that the line is a solid line. And if it's a solid line, it's going to have the or equal to below. So now it comes down to, is it greater than or is it a less than? Now to figure it out, what I like to do is pick a point that I know is a solution. And I know that 0, 0, the origin, is a solution. And a lot of times I like to use the origin to figure out a solution or or where to shade, because zeros are easy to work with. So what I'm going to do is I'm going to put 0, 0 in for my x and my y. So I'd have 1/2 times 0 plus 3 equals, well, I guess here's our question mark. We're figuring that out. What is the inequality? And so when we solve on both sides, I'm left with 0. And we're going to figure out our inequality. That's going to go here. And then I have 0, because 1/2 times 0, 0 plus 3. And so we've got 0 on this side. We have 3 over here. Now we know that 0 is less than 3. And we know it has to have the or equal to sign below it, because the line is a solid line. So going all the way back up to right here, I know what that inequality sign has to be, because I put in 0, 0, and to make it true is the less than sign, and it's got to be less than or equal to since it's a solid line. Can you say I can graph and use linear inequalities? Write a summary and reflection and be prepared for the work time in class.